See, derived quantity, as the name imply, from the name derived, we get it from the what? From the basic quantity. But let's not forget, the units of basic quantity are called basic units. So derived quantity can be obtained by combination of two or more physical quantity, either by multiplication or what? Division. So you can derive quantity from these 6 fundamental what? Quantity, either by multiplication and what? Division. So the example of this derived quantity, we have area. Area is equal to the what? Length times what? The unit for length is what? Is meter, multiplied by what? Breadth. Unit for breadth is also what? Meter. The length and breadth, they are under what? Length. The unit is meter. Unit here is small what? Small m. So what will be the what? The unit for this derived quantity? Meter times meter, m times m, 1 plus 1 will give you what? M square. And the unit of this area here, you call it what? Derived unit. And the next one is what? Volume. Volume is what? Is area multiplied by what? Height. Abi? And the unit for area is m square from here, multiplied by what? Height. This height is h. So the unit for height is what? Is m. So m square times 1m here, we have m cube. What is what? Then what? Density. Density is measured in what? Mass all over what? Volume. But if you look at what? The mass over volume here, the unit for mass is kg. Unit for volume is what? M cube. Abi? So by solve it with law of indices kg, when this one come up, it's m minus 3. So the unit for density is what? Kilogram per meter cube. The next one we have is what? Let us look at speed. Speed is distance over what? Over time. That's the formula for speed. The unit for distance is meter. We know is length. Unit for time there is what? Seconds. We have what? Meter per what? Per seconds. All these units, they are called what? Derived units. All this quantity, we call them what? Derived quantity. And the next one we also have, we have velocity. Velocity is what? Displacement measured in meter over what? Time in seconds. We also have what? Meter per seconds. You can observe that what? Velocity and speed, they have the same what? They have the same unit. So in a calculation, we can use speed to represent velocity. But this speed is a scalar quantity, velocity is a what? Vector quantity. The next one is acceleration. Acceleration is equal to what? Velocity change over what? Over time. Velocity is meter per what? Per seconds. Time is what? This. You will now have what? Meter per second square. The next thing is what? Let us look at what? Force. Force is what? Mass measured in kg multiplied by what? As a what? Acceleration measured in meter per seconds. If you combine the two together, you have kg meter per seconds. That is what? Force. This is derived unit. And you can also call force what? Newton, which is what? N, because it was discovered by Isaac Newton. The next one is let me take work. Work is force. What is unit for force? Kilogram per meter square multiplied by what? Distance. Distance is what? Is meter. So you now have what? Kilowatt. Kilogram m times m square per seconds. That's work done. And this work done, it can also measure in what? In joule. The next one is energy. So energy is what? mgh. Mass times acceleration due to gravity times what? H. So what is mass? Mass is kg. This acceleration due to gravity is meter per second square. This h is what? Is meter. If you now continue it like this, you have kg. Meter times meter, we have m square. And this one will be what? Meter per second square. So this is what? Energy. You can see that what? This energy is equal to what? With work here. Kg m square per second square. So the energy also called what? Joule. So the energy and what? And work done, they have the same unit, which is what? They are also the same. And the both of them are scalar what? Quantity. And the next one is what? We have momentum. Momentum is what? Force, no, is mass. Measure in what? In kg. Multiply by what? What? Velocity measure in meter per seconds. Combine it together, we have kg meter per seconds. The next one is impulse. Impulse is measured in what? Is force. Force is what? Kg per meter square multiply by what? Time. Time is what? Is seconds. Multiply it, it will give us what? Yes, this, okay, here, there's a mistake here. Per seconds. Yes, so here we have what? We have power 1 here, minus 2 plus 1, give us this. You can now see that what? Momentum and what? And impulse, they have the same what? The same unit. So you can use momentum to represent what? Impulse. The next one now is what? Is pressure. Pressure is force in what? Kg meter per seconds over what? Area. What is area? M square. So by solve it further, this one will go up. Minus 2 plus 1, m minus 1, and per second square. This is the unit for what? For pressure. And the next one is power. Okay, let me use it. Power. Power is what? Is work done over what? Over time. What is the unit for work done? kg m square per seconds over what? Time. So it will now have what? kg m square minus 1. When this go up, it will have this. This one, when it go up, it will become what? Minus 3. Sorry. Minus 1, minus 2 here. This is minus 2. Yes. So the next one is what? Stress. So stress is what? Force over what? Over area. So the unit for force, like pressure, kg m this, m square for area, we have what? kg m minus 1 s minus 2. What is the dimension for strain? Is what? Is extension is what? Extension over original what? Original length. Extension is measured in m. Original length also measured in what? In m. Cancel each other. This strain is what? Unitless. Or it has what? No unit. What is the dimension for Young modulus? Or unit? Young modulus, sorry. Young modulus is what? Stress over what? Strain. And the stress unit is what? kg per meter per second square. This one has what? No what? No unit. The unit will now be what? kg meter square. The next one is velocity gradient. So velocity gradient is always what? Velocity, which is meter per seconds, over what? Meter. Velocity gradient is what? Is velocity over what? Over length. Cancel each other. It will have this. If you have to find temperature gradient, it should be what? Temperature over what? Over length. If you have to find pressure gradient, it will be what? Pressure over what? Over length. So what is the unit for frequency? Frequency is 1 over what? Period t. T is seconds. You have what? Per seconds. See, but I cannot show the what? All the unit of derived what? Quantity. So derived quantity are quantity that is derived from the what? Combination of two or more what? Fundamental quantity based on what? Or binomial quantity by multiplication or what? Division. So the next thing we need to treat now is what? Dimension quantity and dimensionless what? Quantity.